parametric function x is e to the t plus e to the negative t, and y is 5 minus the radical 2t. Hey, that's not radical 2. That's just a 2. And then take a look at the function. We have to have it go from 0 to 3 according to the directions for t. And as you can see, it went off to the right, so I need to change the x a little bit. Maybe 20. Okay, so now we need to find the length of that thing. So let's see. Trace at 0, it is at x equals 2. What I would like to be able to do is estimate what the answer is going to be. So this is at 2, 5. Yet by the end, it's at approximately 20, negative 1. And it doesn't make a straight line, but it's not like it's sine or cosine or something. It's almost straight. So if we did use a straight line as an estimate, then the actual length is going to be a little bit bigger than my red line estimate. But I can easily find out the length of this red line by making a right triangle. So this goes from 2 to 20, so this side is 18. This goes from 5 to negative 1, so this side is 6. So if I call this the distance d, then d squared equals 6 squared plus 18 squared. So if we take the square root of that, that's a distance of 18.974. So this curve, of course, is a little bit longer than the straight line. So if I get an answer that's 20 or 21, then I'll be satisfied. If I get an answer of 43, I'm going to be skeptical. So to find the arc length, you take the derivative of both the x and the y, square them, add them together, and put them in a radical. So we're going to have integrate from 0 to 3, this square root. So taking the derivative of this x is going to be e to the t minus e to the negative t. So e to the t minus e to the negative t squared plus, take the derivative of the y function, that's going to be negative 2. Okay, then we need to multiply this out. So if you have this raised to a 2, you multiply the exponents. So that's going to be e to the 2t. We then need to multiply these two things and double the answer. When you multiply the two, the exponents are going to cancel. You get e to the 0, which is 1. In fact, negative 1. Then we need to double that, so negative 2. And then this, when you square it, is going to become a positive e to the negative 2t. And this, of course, is going to be a 4. Next, we can combine the negative 2 and the 4. So e to the 2t, this together with this will make it a positive 2. Alright, now how are we going to actually integrate this thing? Well, for one thing, with having a square root, it is extremely difficult to integrate. So that in itself is sort of telling me, if we're supposed to get an exact answer for this, most likely the radical can cancel, which means that you've got the square root of a square. Well, and hint number 2 is, if you look at this, when we multiplied it out, so when we squared this, we got this thing with a -2 in the middle. What we're left with right now is almost the exact same thing, but with a positive in the middle. So that leads me to believe that you could factor. And in fact, it should factor into a perfect square. So if we have e like this was, except instead of having negative in between, have positive in between. So if we have e to the t plus e to the negative t and square it, is that the same as this? Well, the middle term would be this times this, and then double it, which is going to be e to the 0, 1, doubled is that 2. It works. Alright, so the square and the square root cancel, so what we're really left with for integrating is an e to the t plus e to the negative t. Let's continue over here. So the integral is easy enough. We've got e to the t, and then because of this negative exponent, this one's going to be minus e to the negative t, and then evaluate from 0 to 3. So we will have e to the 3 minus e to the negative 3 minus e to the 0 minus e to the negative 0. Well, this is a 1, and this is 1, so subtracting those, they're gone. So we really just have this part. So then, how much is that? E to the 3 minus e to the negative 3, 20. Very good. So the estimate, like I said, is an underestimate, and an answer of 20.036 is very believable.